Hey everyone, and welcome to the show. My name is Adam Keller. If you're not familiar with me, I am a developer advocate on the container service team here at AWS, and I talk about all things containers on AWS, and especially here at Containers from the Couch, we talk all things containers, all things AWS. Whether that's ECS, App Runner, Kubernetes, open source. We definitely touch on a lot of topics here. So just first and foremost, if you're new to the show, we do have a channel on YouTube, containersfromthecouch.com. Check it out. Hit the subscribe button if you're interested in getting notified when we release new content. So that said, this is my first time actually streaming to LinkedIn. So for our LinkedIn friends, hello. I see Waleed there. Hello, Waleed. Good to see you. He is I believe, a container hero. Really, really awesome. Okay, now he's everywhere. I see Waleed in Twitch and LinkedIn. Unbelievable. He's approaching from all angles. So we really try to get out there and broaden our reach to everybody that wants to watch and join us. So today, what I want to talk about on the show. So I'm going solo today. You'll notice it's just going to be me. So feel free to, take advantage, ask questions. One thing that's really important to us as we do these live streams is if there's a question you have or there's a topic you want us to touch on, bring it up in chat. If it's something I can't answer right now, I may say, hey, let's talk on, DM me on Twitter. We can talk through this, whatever that is. So for today, what I wanted to do was walk through AWS App Runner and the newly released VPC connector functionality, but I wanted to do it in a way that was a little more detailed than what you may see, at launch time, where we have maybe a more simple example or something kind of straightforward. So what I did today was, or what I built was a demo using the AWS CDK. So if you're not familiar with the AWS CDK, this is basically a way for users to express their infrastructure as code using a programming language that they may be familiar with, like TypeScript, Python, Java, .NET, Go. I think I nailed all the languages that we support there. And, with that, you get to take advantage of these native constructs, that you get with your programming languages. So if I want to have more control over how I build my infrastructure, I want to add conditional statements. I want to write some custom logic in my infrastructure as code to, maybe do whatever it is that my business needs or, that we need as a team. I can do that within my CDK code. So we're going to walk through that. And as I go through, if you have any questions, please feel free to ask. And let's get started by just sharing the repo. So I'm going to paste this in the chat for everybody that, in case you didn't see it, here is the GitHub repo for the workshop. Now, this is on my GitHub page here. Basically, what we do, and actually, let's just go straight to it. I'm going to, if you haven't hit the link, let's go there. I'm going to share my screen. And I'm kind of doing this on the fly here. So let's do this. Let's share. We're going to go to the screen here, share my window, and we're going to go right here. Okay. So this is the repository here. So actually, let me get that up. Add it to stream. There we go. Okay. Now I'm going to zoom in. So this is the GitHub repo. So it's basically just Adam J. Keller App Runner VPC Connector demo. So I highly recommend after this, head to this repo, read through the documentation. So one thing that I really like to do when I publish walkthroughs or workshops is, in addition to the code and all this, the resources that are available within the code, I try to explain the why and the rationale behind the decisions we made when building this workshop. So a couple things you'll notice in the workshop is, the links are not shared in LinkedIn. Thank you. So you'll see it's pretty straightforward. When you go to this, this repo, It's just CDK deploy, and then you're going to have your environment magically up and running. Well, that's cool. I really wanted to make sure that folks could actually understand, okay, they're doing this. Here's why they're doing it. So as you go through, I explain the application, and basically, what I'm doing today is I'm going to deploy a front-end service. This is an API, and this API service does a couple of things. One, it's first of all, it's publicly exposed on the internet. Okay, it's an API that's publicly exposed. And the job of this API is to do two things. One, it's to register any user that hits the endpoint. We're going to just collect their some information about that session. And we're going to just store it in a backend database. Now, that database lives in a private VPC and private subnets. This is common. Generally, we don't want to just publicly expose our databases to the world, out to the internet for anyone to just access, right? So what you'll see here is we're talking to a database that lives in a private VPC in private subnets, and we're also talking to an ECS service. So I have an API that's running in those private subnets as well, that's running on AWS Fargate, on Amazon ECS. So those are the two back-end resources that we need to talk to. Now, let me take a step back and just explain, what is AWS App Runner. So if you're not familiar with App Runner, AWS App Runner is it's a fully managed service, and basically it abstracts all of the heavy lifting, all of the underlying infrastructure from the operator or the developer, and all they have to do is provide their code or their container image, and App Runner will just handle the rest. So what is the rest? We talk about, when we think about building an environment, deploying your application, what does it take to get your application from your laptop, from your workstation, into an environment where it can serve real traffic and actually run as you need to serve your customers? Pipelines. So App Runner, if you use whether that's a source code based service or an image based service. So there's two entry points for a user to App Runner. It's here's my source code, here's my GitHub repository, here's how you build my application, here's how you run my application. That's one. That's the source code based service. And then two, there's the image based service. So the image based service is here's my container image, App Runner, run it. So you can launch off of a public image in Amazon ECR or a private image running in your account. There was a good question that came up that I want to address. And let me go back to here. So the question was, are we running Route 53 in the VPC2? So we'll talk about this in just a moment, but App Runner, essentially, in order to connect into my backend VPC, what we have to do is instantiate a VPC connector, which we'll walk through as we go through the code. But this VPC connector is going to not only allow my App Runner service to egress, so traffic comes into my App Runner service, and then when it egresses out to talk to my database or my ECS service, it's doing that through the VPC. So I have a Cloud Map service discovery namespace for my ECS service. Now, Cloud Map behind the scenes creates a private hosted zone in Route 53. And because I have DNS propagation enabled at the VPC level, I can resolve that host name from my App Runner service. So that's how App Runner is actually able to talk to my service in ECS over service discovery. So we'll talk more about that in a little bit. But yeah, thank you for asking that. And someone asked where Brent is. Brent is wonderful, awesome. I miss Brent. Brent has moved on to another company, doing amazing things like he always does. So if Brent's watching, he sometimes, will watch the show. Hey, Brent. Okay, but we also have other, great hosts on the show. So if you see Justin every so often, Justin actually goes on way more than I do. So let's get back to the repo here. So there are a few resources here, but I want to go back to App Runner before we dive in. So pipelines. So App Runner can automate the CI/CD of your service. So if you want to automatically deploy every time you push a new image or every time you push to trunk or a specific branch in your repo, App Runner will have that CI/CD pipeline behind the scenes. App Runner handles those deployments too. And the mechanism that App Runner uses to deploy your new services or an update to your service is blue-green. So essentially, health checks are very important here, but App Runner will bring up the new code in parallel to your existing service as it runs, health check, and once it's good, it will redirect traffic over to that new app. So that's all built in. So when I say there are pipelines and all this built in, you don't actually have to think about this ever because App Runner's managing this for you. Auto scaling is built in. Typically with auto scaling, you have to think about what metrics do I need to collect? How do I then take those metrics and actually take action when they hit a certain threshold? App Runner manages all of that for you. And App Runner specifically manages auto scaling on one metric, which is concurrency. So the number of concurrent connections to a service at any given time. You can tweak this, but I believe the default out of the gate is 100 concurrent executions, 100 concurrent connections at a time. So that's all managed for you too. And you can configure how you want to scale in and out, and you can tweak that number. And then load balancing. So load balancing is built in. Little secret here, App Runner behind the scenes is actually building and deploying your services using AWS Fargate on Amazon ECS. And we actually have a mesh, a service mesh to manage the load balancing and some of the more advanced functionality there. Okay, with all that said though, you as a user of App Runner don't have to think about any of that. So let's go right into the application here. And I'm going to start by running a CDK deploy. Okay, so I'm going to deploy all the resources. Let me stop sharing my screen because otherwise that'll get crazy. And what we're going to do is then talk through the code as it's deploying because there's quite a bit being built as we deploy here. So let's get my screen share going again. And this time we're going to share my editor. So here we go. So here's my editor. Okay. So the CDK, there's a couple ways you can instantiate your CDK code base, like just to get started. There's with the CDK command line interface, you can just say CDK init, and then you can pass in your language, whether that's Python, TypeScript, Go, etc. And it will actually build a skeleton framework for you to just get started right away. And then there's also the option of using Progen or Progen. I'm not sure what the exact pronunciation is there, but this is an open source tool that's basically a project generator. And Progen will build not only all of like the skeleton framework that you need to get started, but it'll also add in other commonly used tools and mechanisms to get you going. And these are kind of like day two things, like Dependabot, managing your dependencies in your application, and notifying you and having automated pull requests to patch those your package JSON and keep everything up to date. So check out Progen. It's a really cool project to get started really quickly with CDK projects as well. So this here is just my application. With CDK, you instantiate your application. Your application can consist of a stack or multiple stacks. And when we think of a stack, this is basically just the deployment artifact of your environment, which is the compiled CloudFormation that's getting deployed. So I'm in my CDK repo here. I'm going to just type CDK, deploy, require approval, never. So when you deploy resources to the CDK, if you're modifying anything like an IAM policy, and I love the community here helping out. Thank you so much. So here is the Progen link to check it out. And thank you, Blake. Well said. I already have an error, so let's see what I did wrong. But yeah, so the batteries included version of CDK init. Nicely said. Okay. Oh, so I just need to AWS ECR. So because I'm doing this from the command line, I am pulling images from ECR public. Now, to do that, I need to log in. I need to Docker log in to ECR so I can pull those images down. So that was what that error was. But now we should be good. So this is just my CDK app. Okay, this just defines, here's my stacks that I want to deploy, and any environment parameters I want to pass in, and so on. They're all here. Now, the real meat and potatoes is the stack itself. So as I'm deploying the stack, it's going to, you can see in the bottom here, as I'm running my deploy, it's actually going to basically create a CloudFormation change set behind the scenes. So it's going to check what's the difference between what I have deployed now, if anything, versus what are we actually going to deploy. So this really doesn't matter right now because that change set is just saying we're going to deploy a bunch of new resources. But where this really helps is when you run a CDK diff. So you're proposing a change and you want to see what's going to actually change. Running a CDK diff is going to tell you, here's what we're going to change. And so you get a good understanding there. Okay. So let's just start with the code here as it's deploying. So I'm creating a VPC. Now, if I had an existing VPC I wanted to deploy into, I could absolutely do that. I can import an existing VPC using that VPC construct. One thing about the CDK that I just love so much is the CDK provides these opinionated constructs, and they're in levels. So you have your level 1 constructs, L1, which these are direct mappings to CloudFormation. So I'll show some examples below because we actually do that in this code base. But then it goes all the way up to your L3 constructs, which basically define one or many resources, but in an opinionated way. So, a great example of an L3 construct is the load balanced Fargate service. So I can, in basically 6 lines of code, define a load balance service that's running on Amazon ECS with AWS Fargate for the compute, and it's going to build a load balancer, attach the target groups to the load balancer, attach my ECS service to the load balancer and target group, and kind of do all of that heavy lifting without me having to really do a whole lot, except say, here's the CPU, here's the memory I need, and maybe the name of my service and so on, and here's my container image. So, yeah. So when you think of the L1 mapping in the CDK, that's exactly what it's doing. It's mapping directly to CloudFormation resources. So at least in with the CloudFormation as the artifact mechanism to deploy our CDK code. So let's actually show. So while we're here, I'll show you an example of what that means. So here I'm creating an app runner VPC connector. So this connector is, I'm using the CFN VPC connector construct. This maps directly to CloudFormation. So everything I'm doing when I define this resource is a one-to-one mapping to the CloudFormation resource in AWS. So generally, when there is a higher level construct, it's recommended to use that because that's going to abstract a lot of the boilerplate CloudFormation templating. So you don't have to think about that. You're just passing in higher level parameters, and then the CDK is actually building the CloudFormation on your behalf. So this will just ultimately, these constructs just one-to-one mapping of CloudFormation. So going back up, I'm just creating a VPC. This VPC, I'm using the defaults. So this is an example of like an L2 construct where I can take a just bare bones, one line of code, and this is going to build off of good practices, a VPC with private subnets, public subnets, as well as all the route tables, all of the work that has to go into creating a VPC. It's all done here. Good practices, out of the box, good standards, if I just use this construct. Now, you can always extend on this. So if you don't want to use the default VPC construct and you want to customize this, you can. And what I love about working with the CDK and the IDE is just in VS Code is such a nice experience here. But you can see there's so much more I can do. So if I want to enable flow logs, VPC flow logs, I want to not have any NAT gateways. I want to choose the CIDR ranges for my IP addressing. I can do all that. But in this case, I don't need to, so I'm not. So I'm sticking with the defaults. And then I build an ECS cluster. So because again, if you remember in our diagram, we are talking to back end, an ECS service running an ECS. So to do that, we do need an ECS cluster. Now I want to say with ECS, the concept of a cluster is not what you may think when you think of clusters when running container orchestrators, because it's literally just a namespace for how to logically organize and run my tasks together. But I don't have to think about upgrades of the cluster. I don't have to think about versioning. It's a fully managed control plane with ECS. So I'm just saying, here's where I want to logically group my tasks and my services when they run. So when I create my cluster, I'm saying, here's the VPC I want it to run in, as well as the cloud map namespace. So when you're operating containers at any scale, you're going to get to a point where one container or one resource in your environment is going to need to communicate with your containers running in ECS, right? So if you're running in a cluster, something's going to need to communicate with your service at some point. Maybe not. But if it does, this is where you need to determine, how am I going to communicate to my containers? So there's a couple options. There's service discovery, which with ECS uses AWS Cloud Map natively built in. Basically, the integration is built in. Or do I want to communicate over a load balancer? So if I want to run my service behind a load balancer, my tasks behind like an ALB, application load balancer, I can do that as well. So really, it just depends on the use case and what the traffic patterns look like. But in this case, I want to associate a service discovery namespace to my ECS cluster. So this is how we do it. And the last thing I'm doing is just enabling ECS Exec at the cluster level. So when you, with ECS Exec, if you need to like execute a shell in a running container, if you're running on EC2, like your containers in the cluster are running on EC2 instances, you can always SSH into the host, and then Docker exec into your container, which, I will say always, if you're doing this in production, of course, these things need to happen sometimes when things go wrong, but have ways to investigate and have some sort of, logging security measures in place to make sure that when people do this, what they're doing and so on. That's my disclaimer. I'm done. But for Fargate, if you need to execute a shell in your container, with AWS Fargate, the underlying host is fully managed. You don't have to actually manage that underlying virtual machine. So with that, if you need to access, that's where ECS Exec comes into play. Through the command line, you can ECS Exec into a running task, into a running container on AWS Fargate. So I'm enabling this just in case something goes wrong and I cause a fire here. I may want to execute a shell in my task to see what's going on. Okay, so that's it. That's ECS stuff. Before I continue on, and by the way, we're still deploying. So we're deploying an RDS cluster. This takes a little bit of time. There was some conversation here. So let me go back. So yes, thank you, Blake. All L1 constructs have that CFN prefix. So that's how it maps directly to CloudFormation, because it's going to be CFN blah. So yeah, thank you for that. Is there an L3 construct for App Runner? So at this time, not that I'm aware of, but if this is something you're looking for, I would recommend going to either the CDK, the CDK GitHub repo, or the App Runner roadmap. Submit a GitHub issue, explain your use case, why this would benefit you, and let's get some people behind it, start giving it thumbs up, and then we're good. So right now, my understanding is AWS App Runner in the CDK only has that are native, only has the L1 constructs, which map directly to CFN, CloudFormation. But thank you, Waleed. There is constructs.dev, which is where the community contributes these open source constructs that you can use as well. So this is a really great way to, if there's a construct you're looking for that's not natively built into the CDK, there's a community that builds constructs and uploads them to the construct hub, which is where you may be able to find something that you're looking for as well. So thank you, Waleed. I appreciate that. Yep, it's the construct hub. So perfect. Okay, so I think we addressed all the questions. Let's just go back. I think we're good here. Okay, perfect. So our deployment is done. And before I show anything, let's run through the code some more. And let me know if you want to just see it, and if the code review is getting a little boring, I can stop that as well. But I like to go through the code because I really want to show how we're building this environment. So we have our database cluster here. Now, oops, click the wrong thing. Okay. So again, what I'm doing here is I am taking advantage of a construct, which is a higher level construct that is going to build one or many resources, AWS resources, on my behalf. So here I'm taking advantage of the serverless cluster construct for Amazon RDS. RDS is our relational database service. Essentially, it's a fully managed database offering that provides you a database cluster. We manage the underlying virtual machines, patching, and all that good stuff. So RDS is awesome. Now, in addition, we have Aurora. So Aurora is our database offering, Amazon Aurora. And we have the option to run a serverless cluster. So a serverless Aurora cluster is essentially where we will scale in and out the database cluster as needed, as requests come in, and as traffic, ebbs and flows. So what's nice about a serverless RDS cluster, obviously, is you don't have to pay for resources when you're not using them. So we will scale in when you're not using any, when you're not talking to the database, and then when you need to access that database and scale out, you only pay for the resources you use. So generally, when you build an RDS cluster, you have to think about subnet, like your database subnet groups. Like there's configurations that you have to set when you build your RDS cluster. In this instance, I'm just passing to this construct. Here's the database cluster engine I want to use. So I'm using Postgres here. Postgres is popular. I personally like MySQL. I just happened to decide, you know what? Let's refresh my memory on Postgres and remember why I'm so bad at managing databases. This is why I love RDS, because in my past life, not only have I managed container orchestrators at scale and built and designed them, the environments, but I've also had to deal with databases. Let me tell you, I'm not a DBA. Don't judge me. Sorry. So when you see my actual code and you see how I'm interacting with the database, please don't make fun of me. That's an area where my brain just doesn't function well. So that's why we have people that are really good at that, and we got to leverage those people. So anyway, this is my cluster. I'm saying, here's my VPC. Here's the version of Postgres I want to run. And then here's how I want auto scaling to work. And also this removal policy. This is nice for, when you're testing something or you're building, dynamic environments. So it's common that folks to, serve their development teams. Maybe there's a platform team that on pull requests, someone submits, a pull request, it builds an environment dynamically. And then when you remove that environment, you want to make sure that all the underlying resources get destroyed, such as, your log groups. Sometimes, like with RDS, there will always be like a snapshot that persists after you delete it, unless you explicitly say delete the snapshot. So I'm just being super aggressive here, saying get rid of it all, destroy it. Okay. Last thing to mention, enable the data API. So this is important because we are actually going to communicate with Postgres over this data API, which is also how we're going to use IAM authentication to communicate as well. Okay, So I created my database cluster. Now, this is one of the, like my most favorite constructs within the CDK. So the CDK abstracts a lot of this heavy lifting away from you. But there's going to be times where you'll run into a limit. You're going to run into a limitation, I should say. A limitation within CloudFormation, something's not supported that you want to do. So in this example, I'm creating a database cluster. And one thing about me, I love automating everything. So when I was building, an infrastructure at scale and building pipelines, one thing I always wanted to do was automate everything I could that was within reason, right? Like you have to be reasonable. You can't automate the world. There's going to be some things that just have to be manually done. But in this case, whenever I can, I want to automate things so I can focus on other stuff and continuing to improve our environments in other ways. So anywhere where I can check a box and say, I don't have to deal with that, that's where I tend to gravitate because I know the management and everything that goes into having to do that on your own. So I try to offload that. So in this case, I need to, when my database is created, my database cluster, I want to create a database for my service, but I only want to do it when I run, when the CloudFormation deploy runs and when it's creating resources. So every time I create this database, this database cluster, I want to be able to run a command. So the CDK has this custom resource construct, which will actually create a CloudFormation custom resource on my behalf. Now, CloudFormation is super powerful. And one of the other reasons why I talk about the CDK a lot is, and I talk about using opinionated tools in general, is because CloudFormation is deep and it's very expressive, and there's a lot that you have to know to deploy resources through CloudFormation. So here in my code, even to create a custom resource in CloudFormation, there's a lot of inputs and outputs that you need to be aware of. The states, create, on update, it's on update, on create, on delete, and so on. And you have to create a Lambda function. There's a lot that goes into it. So what this construct does is it does all that for me. And all I have to do is say, when I create, okay, so on create, every time we're running a create call in CloudFormation, for this resource, I want you to run this command. So when I create the database cluster, it's going to run create database app runner demo with owner Postgres. So now I'm using my infrastructure code in the same place. I'm able to also automate the creation of my database. Now, again, every environment's different. Maybe you do this in your database migration in your code, right? If you're, Ruby on Rails or whatever you're running, you may have your own DB migrate scripts that you run. But this is a great way for me to provide an environment that when it's launched, that database is there ready to be fed data, and it's ready to go when it's done creating. So that's one. So I use this custom resource construct. So why do we use custom resources? When we want to address scenarios that are not available, right? A functionality that's not available within CloudFormation or the CDK, this is a great way for me to extend on that. And the alternative to custom resources would be I'd have to figure out in my own code when the database is created. So I'd have to have some wait command to wait, say, is the database cluster there? Okay, then issue this. Did it happen successfully? And so on. I don't have to do any of that. Custom resources handle that. Now, I probably could have been a little more creative here and like merged these commands into one, but I wasn't able to do that. So what I did was I created another custom resource, and this second custom resource creates a table in my database. So I'm just creating a table, and again, this table is for my front end. Every time a user hits the front end app, we log some information into this back end database. And then I'm just, again, I tend to repeat myself, so I'm sorry for that, but just one of these, again, using the expressiveness of a programming language, there are helper methods available in these objects. So I'm creating this custom resource object. Now, within this object, what I need to do is I want to add a dependency. So I want to make sure that you don't create the table until you've created the database in my database cluster. And you can't create the database until my database cluster is up and running. So here's where I'm able to add these dependencies with these helper methods. And also, one of the benefits of using these constructs, this database cluster construct, the serverless cluster, is it's going to create a secret in Secrets Manager for me. And it's going to store all the relevant information for my database, the port, database host name, user, like the super user, as well as the password. That's all stored in Secrets Manager as a part of this construct. Do you see me defining a Secrets Manager construct anywhere? No, because this is the benefit of taking advantage and leveraging these higher level constructs, because they have good practices built in, right? You shouldn't be creating this secret outside and then storing that secret in your code. This is like the age-old question is how to manage secrets. So if you're creating secrets dynamically, you don't have to think about managing them or rotating them, because that can all be built in. Let me rephrase that. You can think about rotating them, but it's in an automated way. So that's all built in here, and you can build on that if you need to. Okay, using helper methods, I'm allowing connections. So if you're familiar with, AWS, you're familiar with security groups, VPC terminology. Typically, I'd have to define a security group. In that security group, I have to define what connections I want to allow to my database. So here I'm using, again, one of these helper methods to allow that traffic. Okay, now for my private service, this is where we're going to run in ECS. So we have our cluster created, and I'm going to create a task definition. It's bare bones because look at the task definition. When we create a service in ECS, when you launch a container in ECS, it's generally like a 3-step process. One, you have to define your task definition. This defines what containers you want to run, what resources you want to allocate to those containers and to your task as a whole, and any other dependencies that your container may have. So environment variables, volume. So if you want to mount an EFS volume to a specific path in your container, you can do that in the task definition. So in addition, so like I was saying, here's my container image, here's the port I want to run on, and then here's how I want to log. And I promise you, we came here for App Runner. We're going to get to it very soon. One other really nice benefit of the CDK is it does have this functionality to build a container image from an asset on your file system. So you notice here, I'm saying, here's the container image I want to use to run my service. I'm just pointing it to a directory. So if you look here in private service, this is where I have a Docker file, I have my code and everything running. And all I'm saying is, here's where my asset lives. You build the container, you create the ECR repository, and you connect my resources together. So you connect my ECS service, the ECS orchestrator, to ECR to make sure we have the proper permissions to pull that image down and so on. And then I'm going to build an ECS service. So I've defined my task definition. I've defined what containers I want to run in my task definition. And then I have my service. So now the third step is, how do I want to run this now? I can run it as a long-running service, which is where basically I say, here's how I scale, or here's the desired count of tasks that I want running. Or, do I want to run it ad hoc? So this is where maybe you're using you have more batch processes running, or you want to run like a cron, where you run a scheduled task, where it's not long running, but it runs every day at 12 a.m., for an hour. So just depending on how you want to run your container will determine how you define that in your code. So I'm defining this as a service. Here's what I want to name my service. So this is the DNS friendly name I'm going to give it in service discovery. And then I want to run it using Fargate Spot. So I want to take advantage of some cost savings there. Okay, now we're going to get into our App Runner service. So I'm just going to quickly check the chat here. Any questions? It's kind of quiet. I feel like everyone's sleeping. So hopefully you're not sleeping and you're enjoying this. But if you have any questions, please feel free to reach out here in chat, say hello, or whatever it is you're thinking. We're here to help each other. So with our VPC connector, actually, you know what? Do I want to share my screen and go back to, I think I may. No, let's run through this. Okay. So we start with defining our VPC connector. Now, with an app runner service, you have your publicly facing app runner service, right? It's running behind the scenes. I gave away all the secrets. It's running as a container behind the scenes, and we're load balancing the traffic to that container for you. Now, that's publicly available. So if you need to access resources outside of your VPC, for example, you want to access DynamoDB, unless you have a requirement that you have to access that DynamoDB table from a VPC endpoint, you can just access that over the internet. And the way you control access to your DynamoDB table is through identity and access management. So I don't need a VPC connector there. But because we have resources in our VPC that we need to talk to, this VPC connector is what's going to connect us, our app runner service, to enable that communication from our front-end app runner service to our services running in a private VPC. So there are some controls here we have to think about. One, what subnets do I want to connect my app runner service into? So that's one, what subnets? So here, what I'm defining, again, because CDK is so powerful with all of these awesome helper methods, I am using I'm saying these are the subnet IDs, which is the private subnets that I want to connect into. The next thing is, how do I actually communicate with these services? So now I'm in the subnets, but with AWS, everything, when you build resources in AWS, when you build a database cluster, when you build a DynamoDB table, by default, it's least privileged security. So there are 0 permissions to enable A, network communication, and B, identity, authorization and access. So out of the gate, there's 0 permissions there. It's up to you to define what access network communication you want to enable and what authorization you want to enable for your services as well. So from the security group's perspective, I am saying we're going to use this security group ID, and you can have multiple security group IDs that you pass in here. But in this instance, I'm just saying the database security group is the one I want to connect into, because I cheated a little bit. And if you noticed up here for my private service, I'm just saying I want to allow all traffic to my private service on port 8080. So I'm not restricting anything. So that's why I didn't need to attach that security group here, because I'm saying it's wide open for this particular service in my VPC. So, okay. So that's that. Now we've defined how we want to connect into our VPC. Okay. Now with App Runner, we have to have a service role. So a service role. So this is common in ECS too. So I had posted with Justin Garrison, we had done a fun thing with YouTube Shorts. I posted a short on ECS, the difference between a task execution role and a task role. It's the same here with App Runner. There's an instance role and there's the service role. The service role is what allows App Runner, okay, so the App Runner service, so all of the stuff we're doing behind the scenes is what allows App Runner to actually do these, interact with these AWS resources on your behalf. And the main one here is for our build service. So when we build your container image, it's allowing us to pull that container image from ECR. So that's the App Runner service role. Then there's the instance role. The instance role is saying, here's my code. Here's my code running in App Runner. I need to talk to AWS resources. Okay, so maybe it's an S3 bucket. That instance role needs to be attached to enable that access from my App Runner service to that S3 bucket running in my account. So you can see here, I am pulling secrets in my code. I talk to Secrets Manager. It's a really good practice when you're interacting with AWS resources, when you need secrets, you never want to hard code those into your code secrets, and you especially don't want to hard code those as environment variables. So what I do is I actually hard code in the environment variable the secret name, but I have to talk to Secrets Manager to actually pull that secret down. So that's all I'm doing here is to my instance, I'm saying you're allowed to get the secret value from Secrets Manager for this particular secret. Here's my ECR image. And now I'm defining my app runner service. So I can do this all in the console, by the way. And if you want to see that, let me post this here. I do have a more simple demo walking through AWS App Runner, how to get that deployed. And this does it in the AWS console. This is a more simplistic demo. So definitely check that out if you want to see what that's like and just how to interact with App Runner from the console perspective. And you could be very successful deploying the App Runner to App Runner from the AWS console, by the way. Okay, so back to my service here. I'm configuring automated deployments. Here's my image, my ECR image. So every time I update this image, I expect App Runner to trigger a deployment. So CI/CD built in, okay? And then here are the environment variables for my app. So in order to talk to my backend service, I don't want to hard code like a service URL. So basically, I'm just saying, here's that ECS DNS record, and I'm just creating a web address to access it over port 8080. Here's the name of the ARN actually for the secrets for me to talk to the database, because I talk over, I issue a pSQL command basically. And then just because I use this app for other things, I am saying here is the just basically my code says, is this an app runner service? If true, do this. Setting up authentication, just that identity stuff that we talked about earlier. My network configuration. So this is, again, confirming that we can connect to the VPC that I've defined above. And then here's my service name and just some other stuff there. That's it. So you can see here, I was able to define a reusable template, all as TypeScript code. And I can take this code, I can build, I can make, like, for example, the account dynamic, the region dynamic, and I can deploy multiple instantiations of this. I can just, for dev environment, test, stage, prod, I can reuse this for all those environments. And that's the idea with infrastructure as code, is you build once and you reuse it everywhere. So, there's always a little work that goes into building infrastructure as code. But I'll tell you, the benefits, in my opinion, really outweigh the cost because, again, with CDK, high-level constructs, opinion built in. So a lot of things I'm not thinking about. If this was CloudFormation, we could run a CDK synth, and then I could pipe it to a word count. And so I have like 260 total lines in my code here. But if I were to run a CDK synth, and when you run a CDK synth, what that's doing is that's taking this code and compiling it into CloudFormation, into a CloudFormation template. So basically 260 lines of code equals 1,076 lines of CloudFormation. So that's 1,076, that's 800 and something math lines of code, CloudFormation code that I didn't have to write. Pretty good, right? Okay, so let's go to the console now, because I've been chatting about this code for so long. We're going to stop sharing this screen. And now I'm actually going to go back and share my, let's see here, this. Don't be startled when you see me yep, there it is. Okay. You see me all over here. Okay. So now let's go to my account, and we're going to go to AWS App Runner in the console. I'm going to zoom in so everyone can see. Okay. So I've deployed my App Runner service. This is it, App Runner VPC demo test. If I click in here, I can see everything about my App Runner service that is relevant, that matters to me. Okay. So one, my default domain. Let's just hit the endpoint. So when you hit the root of this application, what it's going to do, as I mentioned, is it's registering your request in that backend database. I have a few endpoints here. If we were to go to docs, this is a fast API app, by the way, written in Python. So again, the root of the application, when you hit the root path, it's going to talk back to the database and register some details about your session. We also have an ECS private service path. So this is going to communicate to that ECS service over DNS. Again, so remember, it's talking over service discovery to my service running in a private private subnet in my VPC. So if we were to do that, we can go here. And what this will provide, what I do in the ECS service is I actually just pull the task metadata and I return that as a response. So again, that's an API service that says, here's the details about my ECS service, return. So look at this. I'm talking to an ECS service running in a VPC in a private subnet that's not publicly exposed. And App Runner is able to connect into that service because of the VPC connector functionality that we enabled. So there's also, and what I can do too, just so you don't think I'm being sneaky here, I'm going to go to ECS and I'm going to kill that task. And let's remember the IP address ended in 128, okay? We're going to go to my cluster. We're going to stop this task. And let's hit stop. Stop. Okay, I'm so zoomed in. So hopefully everybody is good with all the zoomage here. Go back to docs. Oops. Bad typing. So let's now, if everyone wants to hit this endpoint, please, feel free. Again, it's just basically, I'll actually show you the code here. Demo app main.py. Oh, actually, I can't. I got to go here to show you the code. Forgive me. So demo app main.py. So all I'm doing in the front end here, when I register your call to the backend database, is we go to the root here. I'm just taking the user agent out of the headers and putting that, logging that in the database with a timestamp. That's it. And this is just to show you that you can connect into the backend database. So if we were to go to recent visits, and by the way, again, feel free if you want to hit this endpoint, go nuts, go bananas. It's okay. Let's do that here. I'm going to post this. So this is that endpoint. Feel free to access it. I have no problems with that. And if we go to now recent visits, what we're going to do is query the database for the 10 latest visits there. So you can see I've only hit it, I think, once, and already I'm seeing more, coming in. There you go. See, look at all that. So that's it. So you can see here's who's hitting the endpoint, and we were able to do that by connecting in that backend database, which is all that connection is happening through that VPC connector functionality. So if I go back to my repo here and you look at the diagram, you can see you're accessing the App Runner endpoint. And by the way, you can connect this to a vanity URL. Like you can connect it to a domain to get like a nice URL there. I'm just using the default for now. But you can see we have our App Runner service that's running, and it's able to connect into my VPC, talk to my ECS service over service discovery, and it's talking to my database host all through that VPC connector functionality. There is a deep dive blog out there, which let me share that right now for everybody. So this is written by Archana, who is the one of the lead, I think actually the lead principal engineer for App Runner. She's amazing, and she posted this blog, which just dives into how this works, and specifically the technical details with like the VPC, the hyperplane, and how we're able to connect and not consume all the IP addresses. Really cool read. Highly recommend if you want to just see the technical details of all the stuff you didn't have to touch and you didn't have to do. Check it out. So really cool blog to read there. But that's really it. I'm trying to think if there's anything else here. Oh, I do want to hit that ECS service one more time. Let's see. More visits. Whoa, people are curling me. I have a feeling we're trying to hit the, and yeah, just keep sending traffic because it's going to auto scale, by the way, off of 100 concurrent requests. So keep sending traffic if you want. Let's go back to that ECS private service endpoint. And remember that IP address was 135. You can see it's now 163. So we were able to connect to our resources in the VPC all through the CDK. I was able to connect all the components together and do all that really cool stuff. So with all of this said, some takeaways here. If this is something that you're looking to do, you want to get into the CDK, you want to get into App Runner, please check out the GitHub repo. There's a ton of details here to help get you started. Also check out the docs. If you have any questions, you can reach out to me on Twitter. Here's my Twitter username, LinkedIn as well. I'd love to chat about all things containers, anything I can do to help folks get started. But other than that, thank you so much for listening to me, blab for an hour. It's been a lot of fun. And check out containersfromthecouch.com. We've got a ton of content there. We are continuously putting out new content and doing some really cool stuff with that. So thank you so much, everyone. And in the meantime, that's all I have for today. So have yourselves a great rest of your week, great day, and we will talk soon. So thanks again, everyone.